And we're doing the second, or the last part, I guess, the third part of 2D motion practice number 3. We want to know the magnitude and direction of the pumpkin's final velocity when it hit the ground. So this is the same diagram as the first problem. And what we need to find, the crux of the matter here is that, right, so when this thing hits the ground, it's just about to hit the ground here, this is its VF. If I can find these two components, VFX and VFY, then I can find VF and I can find this direction, theta. You could specify either direction here as long as you're clear what you specify. So because the acceleration in the x dimension is 0, I know that the VFX is the same as the VIX. Can't change if there's no acceleration. And that was VI cosine theta. So I'm all set with that. The VFY I'll want to know. I do at this point know the delta y, and I know the VIY, and I know the AY. So what I'm going to set up is this. That's my VIY squared plus 2a. A is negative g. Delta y, and delta y was negative about 83 something or other meters. So VFY is the square root of that stuff. And looking at this right triangle here, I know that VF is the square root of VFX squared plus VFY squared. So I can put these expressions in. So that's the square root of VFX squared, which is the same as VIX squared. So that's that. Plus VFY squared, that just gets rid of this square root here, so we're back to this. So VI squared sine squared theta minus 2g delta y. And I can actually make my life a little bit easier here if I use a trig simplification, though you don't have to. You have enough to plug in the numbers here. Sine squared plus cosine squared is 1, so I can factor that out, and that will give me VI squared minus 2g delta y. And if I plug in those numbers, I get 51.3 meters per second. That's the magnitude of the final velocity. That's the speed that it's going, the total speed. And to find the direction, I'm going to use some trig here. So inverse tangent of VFY over VFX will get it for me, because VFY over VFX equals tan theta, so I just take the inverse tan of both sides. You could also do an inverse sine or an inverse cosine since you know all of these bits. And you have expressions for these, so you can plug those in. And if I do that, I get 73 degrees, so it's 73 degrees below the horizontal. This angle is the same as that angle, so the direction of that velocity is definitely downward. You could also have come up with 17 degrees from the vertical there.